So with example 4, that was the first question they asked us to find absolute maximum, right? So we talked about how to find, we did absolute maximum. There's 2 more questions on here. 5 and 6 are absolute maximum, absolute minimum. I'm not going to do both of them. I'll just do one of them, okay? Because number 5 is the same question, just the only difference is they're asking you to find absolute minimum. The only difference is you would do exactly the same thing you did on number 4. The only difference is you would look for which of these guys is the lowest, right? We were looking for maximum on the last one, so we said -1. So we said this guy was the biggest, right? The biggest y value. The only difference with minimum is you would be looking for the lowest. So in this problem, they didn't ask this, but this guy at -5 would be the absolute minimum, okay? That's the only difference. Everything else is exactly the same, okay? All right, so I'm going to skip number 5. I'm going to go to number 6. So go to number 6. Still an absolute maximum or minimum question, but I think that one's a better question, okay? So absolute maximum and minimum, we start exactly the same way we did with relative maximum and minimum, okay? So we need to find absolute maximum and absolute minimum. So when they do absolute, they're always going to give you an interval. They'll always give you an interval. With relative, they won't. But absolute, they'll always give you an interval, okay? So absolute maximum, absolute minimum. First thing was find the derivative, right? Find the first derivative. Well, it's a division problem, so we have to do quotient rule. So low squared. So low times the derivative of the high minus the high times the derivative of the low. Okay. So I got to distribute here and multiply. Wait, did I do that right? Yep.
2x to the third? Negative 2x to the third?
Yeah, so it's going to be 2x to the third minus 2x to the third, right? X squared plus...
What about the plus 3?
And I forgot about the plus 3. And I forgot about the plus 3. Yeah, I knew it looked wrong. Thank you. Yeah, I knew it looked wrong at the beginning. Wait, no, that guy...
For the first one should be x squared plus 3, not 2x.
Okay, let me change.
Yeah, you did the derivative of the bottom twice.
Okay, let's see, move this over here. So it's going to be x squared plus 3, right?
Yeah.
That's what it should have been, right?
Yeah.
Derivative of the top times the bottom minus the derivative of the bottom times the top. Okay. Sorry, yep. So this is going to be
2x to the third plus 6x.
Plus 6x
Minus 2x to the third.
minus 2x to the third.
And they're going to cancel out to get this 6.
So the 2x to the thirds are going to cancel out. Oops. There we go. So the first derivative is 6x over x squared plus 3 squared. Okay. Well, this is to find the critical values, right? This is all to find the critical values. So what do we do if we need to find the critical values? Set it equal to 0, right? If it has a top and it has a bottom, set them both equal to 0. Set them both equal to 0, yeah. If it only has a top, set that equal to 0. Whatever you got, set it equal to 0.
The bottom can never equal 0.
And yeah, the bottom is one of those situations where we had before, it can never equal 0. There is no number I can plug in there. You can try forever and ever and ever. There will be no number that you can plug in there that will ever make that whole thing 0. Because even if you plugged in 0, 0 squared plus 3 is 3. Squared is 9. Even if you put in a negative, let's say I put in a negative 3, I'd have to square it first. So that became positive 9 plus 12 squared, 144. So there's no, if you don't know that, you can do it by, you can solve it. Just take the square root of both sides. Then subtract 3 from both sides. And then when I take the square root, you can't take a square root of a negative number and expect to get a real answer. You're going to get it's going to be imaginary. It's going to be imaginary. So in this class, we don't deal with imaginaries. We don't have to worry about imaginaries. So that's why the bottom, the denominator, is not going to give you anything, going to give you an answer. Okay? So when we're looking for relative maximum minimums, we make our number line, right? And then test to see if it's increasing or decreasing. This is where absolute maximum minimums differ. We make a table instead.
What if we get 2 of the same value?
Then it has 2 maximum or minimums. It could have 2 maximum or minimums.
So this one we're going to have 2 maximum?
Mm-hmm. So it could, yeah, it could. So what numbers do we put in the table?
-1, 0, and positive 1?
Exactly, the beginning of the interval, the end of the interval, and any critical numbers, critical values that we found. We only found 1, so we're going to put that there. Now I'm going to plug those into the original, see which one's the highest, see which one's the lowest. So -1 squared over -1 plus 3. +1 squared over 1 squared plus 3. Oh, one thing I should check. I didn't check on this one, but I should check. Make sure your critical value is within the interval. Make sure your critical value is within. If it's not within the interval, you don't even have to check it. 0 is in between, so we're good there. But sometimes you'll get a critical value which is not inside the interval. You don't have to check that because it's not inside the interval. And then the last one is 0 squared plus 3. So the top, I'm going to get +1 over +1 plus 3, which is 4, right? Same thing here. On the bottom, I'm going to get 0 over 3, which is 0. So exactly. So I have absolute maximums. So I have absolute maximums. I have 2, right? At x equals -1 and x equals +1. Because those y values are bigger. Then they're exactly the same y value. And then I have absolute minimum at x equals 0. Why? Because that was the smallest. And you're done. Okay? So that's what you do with absolute. Sometimes it's called global, but that's what. So in lieu of the last problem, in lieu of question number 5, I have 3 more that I want to give to you. The reason I want to give to you guys these is because they're different. Some are trig, some have e's in them, some have roots in them. We haven't really done any of those. So these are the last ones I want to do today. And then we'll do some practice questions. So these are the questions I want you to do. So 7A, 7B, and 7C. So I want you to do 2 things. Tell me where they're increasing and decreasing, and then tell me where all of the relative extrema is. Tell me where they're increasing or decreasing, and tell me where the relative extrema are located. Well, actually, you know what? I'll do 7A with you guys. So 7a. We have f of x equals x squared to the 2/3 power. I mean squared and third root. So we need to find where is it increasing, where is it decreasing, and where are the relative maximum and minimums. Okay? Those are the things we need to figure out. Well, anytime we're finding a relative maximum minimum, we need to find the derivative so we can find critical values, right? Critical values, we need to find the derivative. Well, this is the chain rule problem. We got to find the derivative of the yellow or the green first. The derivative of the green is 2/3 minus one whole, you'll get negative 1/3. Times the derivative of the yellow, the inside, which is just 1. So I get 2 on top, 3 on the bottom, x plus 2 to the 1/3 power. That's the derivative. Right? That's where we stopped last chapter. Last chapter, that's where we stopped. You just found the derivative. Now we're going to use it. Now we need to use this guy. So how do I find critical values using the first derivative? Set the top equal to 0, set the bottom equal to 0. Good. So 2 equals 0, which doesn't exist, right? So, whoops. 3x plus 2 to the 1/3 equals 0.
-2.
What does that say? Oh, so we're going to talk, yeah, we'll talk about it right now. So the first one, the left cannot equal, 2 is never going to be 0. 2 is never going to be 0, so this guy's not going to give me any answers I can use. This guy over here can. Solve for x. So I need to divide by 3. Zero divided by 3 is 0. I need to get rid of the power first. How do I get rid of a third power? What does a third power mean?
What times of
Cube root, right? So really this is the cube root of x plus 2 equals 0. That's really what it is. What's the opposite of cube root? Cube. So I'm going to cube both sides. So anytime you cube a cube root, all that's left is what's inside. What's the cube of 0? What's 0 times 0 times 0? 0. I got rid of the hard part. Now just subtract 2 from both sides. So I got one critical value, and that was at -2.
Can you also just like see what number
Yeah, you could do that, yeah. If you can visually see which number it's going to make 0, you do that. I just wanted to do this in your notes just to show you. But yeah, if you can visually see it, yeah, you can skip those steps, yeah. Some of you can see what would make it 0 because, you know,
So that would
you've
be,
done that before, but.
would that be the absolute or
So here we go. Now, we don't need to find absolute. It's not asking for absolute. So we're not going to make a table here. We're going to make a number line here. Anytime it asks you relative, relative means make a number line. What are you going to put on the number line? -2. That's the only thing, that's the only value that was not, or that was a critical value. So what numbers, what type of numbers do I have to plug in and where?
-3 and -1.
Numbers that are smaller than -2 and numbers that are bigger than -2. And what am I going to plug them into? The first derivative. Good. So yeah, I would probably pick -3. To the first derivative. and see what I get. Remember, I don't care if it's positive. I don't care what number it is. I just want to know if it's positive or negative. Okay? So I'm going to plug in 3. So I plug in 3 to the bottom. Negative 3 plus 2, 1/3. 2, 3, negative 1 to the 1/3 power. What is negative 1 to the 1/3 power? Negative 1, yeah. It's just negative 1 just means the cube root. So negative 1 to the 1/3 power just means what's the cube root of negative 1? What's the number that multiplies 3 times that makes that? Negative 1. So it's going to be 2 over 3 times negative 1, which is negative 2/3. So that means everything to the left is a negative. Okay. Now let me plug in a number that's bigger. Negative 1, 0, 1, 2, any of those numbers. I'm going to pick, you know what? I'm going to pick negative 1. There's a reason I'm going to pick negative 1. It's because of the cube root. Normally I would pick 0, but for this guy I picked a negative 1 for a reason here. So plug it into the first derivative. So we get negative 1 plus 2 to the 1/3. So I get 2 over 3 positive 1 to the 1/3 power. So what is positive 1 to the 1/3 power? Positive 1. Which equals 2/3. Positive 2/3. Okay. Okay. Negative means decreasing. Positive means increasing. Negative means increasing. Positive means decreasing. Okay. So they want us to say 2 things. They want us to tell where is it increasing, where is it decreasing. That's the first thing they want us to tell. How do I do that? Look at your number line. So if I wanted to write it as an interval, where would I say the decreasing was? From where to where?
From negative infinity to negative 2.
From negative infinity to negative 2. Increasing, negative 2, all the way to positive infinity. Because that keeps going. It keeps going and going and going and going. Okay? So we're going to get negative infinity to negative 2, positive infinity, or 2 to positive infinity. Because everywhere before negative 2, it's decreasing. Well, where does it stop? It goes all the way to negative infinity because that's the left. Positive infinities to the right. Okay? That's that. Now we got to go with relative maximum and relative minimum. Okay. Oh, sorry, it should be negative. Let me fix that.
Would that be brackets around the negative 2 or
No, because at negative 2, it's 0. So it's not negative or positive. At negative 2, it's actually 0. So we use, yeah. In this class, almost always you're going to use parentheses. We don't see a lot of bracket stuff in this class. Okay, increasing, decreasing. Okay? So let's go back. Wait, did I get that wrong? I got it backwards, right? Yeah, it's supposed to be backwards. Sorry. There we go. There we go. Okay.
I'm looking at the next one. Oh,
So the next one, or the next problem?
yeah, the next
Yeah. So let's finish this one first. Are we going to have a relative maximum, relative minimum, both?
relative minimum.
Relative minimum at -2 because,
Switches from point.
there you go. We're going to have a minimum because it's decreasing and then changes to increasing. That creates a minimum. Okay? So we're not going to have a maximum. We're just going to have a relative minimum at x equals -2 because f prime of x switches from negative to positive. When it switches from decreasing to increasing, that creates a minimum. Okay? Okay. 7b. It's nothing you haven't done. We found derivatives of those guys. Okay? So the first step, find the derivative. First step, find the derivative. Okay. For this guy, are we going to need to use the product rule, quotient rule, or chain rule? No, none of them. None of them, just the power rule. The derivative,
It's just 1 minus, or no, 1 plus 2 cosine.
so it's going to be 1 minus 2, and then the derivative of sine is just cosine, right? That's the derivative. Okay. Set it equal to 0. So when you're setting these things equal to 0, it's a little different because it's a trig function, but you're going to do it the same way. Get x by itself. I'm not going to be able to get x 100% by itself, but I will be able to get cosine of x by itself. All right, so the first thing is get rid of the 1. Next thing, divide by -2. That's as far as you're going to be able to solve because you can't separate the cosine from the x because the x is the angle, so you can't separate it. But what you can do is answer it. When does 1/2 equal cosine of x? When are cosine and 1/2 the same? Those of you go into your neon sheets, that's where the answers are. Where does 1/2 equal cosine? Mine's not neon, but yours should look like this.
At pi over 3.
So yeah, so it's
Pi over 3 and 5 pi.
pi over 3 and 5 pi over 3. That's our critical values. 1/2, or sorry, pi over 3 and 5 pi over 3. That's how you solve trig equations. You don't solve for x because you can't really. You get as far as you can, and then you go look at your table. Okay? Number line. We have pi over 3, and we have 5 pi over 3.
Wait, where did the 5 pi over 3 come from?
Where is it? Where is, look at cosine, where is it 1/2? Two places. Pi over 3, 5 pi over 3. Yeah. Okay. So now I got to check before pi over 3. I got to check in between 5 pi over 3 and pi over 3. And then I got to check after pi over 3. So any number you want, any value. I would stick to values that are on your green sheet. So before, I would probably pick 0, 0 pi, or 0. Right? So you plug them into the first derivative. So the first derivative was 1 minus 2 times cosine of x. And that's where you put in 0. Cosine of 0 pi. Cosine of 0 pi is positive 1. So it's 1 minus 2, which is negative 1. So negative 1 means it's negative. So over here, I'm going to put negatives. Okay. So now I'm going to plug in something that's in between 5 pi over 3 and, or sorry, pi over 3 and 5 pi over 3. So I'm going to go back to my table. Any of these guys will work. So any of these guys will work. Preferably pick one where cosine is not something ugly, where cosine is 0, where cosine is negative 1/2, positive 1/2, negative 1. So if I had to choose from any of these guys for cosine, I'd probably pick this one, or that one. Because those guys, those answers I don't mind working with. 0, I don't mind working with. Negative 1, 0, but I don't want to work with these guys here. Square roots, I don't really want to do that. So pick one that, so I'm going to pick pi over 2, because that's got a 0. So pi over 2. Pi over 2. So we got 1 minus 2 times cosine of pi over 2. Well, you just saw cosine of pi over 2 is 0. So it's 1 minus 0, which is positive 1. Okay. So I know there's a pattern. In math, we look for patterns. That's what math is. It's the study of patterns in numbers. But don't assume that the next one's going to be negative. So don't assume that this one's positive, this one's negative, this one's positive, this one has to be negative, right? Most likely it's going to be, but check it, because I've seen them repeat itself. Okay, so always double check. So I'm going to pick a value that's bigger than 5 pi over 3. I only got 2 options. And both of them have ugly, oh well, that's all you can do. So you're going to pick 7 pi over 4, or you're going to pick 11 pi over 6. Okay. So 7 pi over 4, I'll pick 7 pi over 4. 7 pi over 4. So I get 1 minus 2 times cosine of 7 pi over 4. 2 times the square root of 2 over 2. Again, I don't care what the number is, I just want to know if it's positive or negative. So you're going to get 2 square root of 2 over 2. 2's will cancel out. So really it's just 1 minus the square root of 2. So which is bigger, 1 or the square root of 2? That's the question. Square root of 2, yeah. Because the square root of 1 is 1. So anything bigger than the square root of 1 has to be bigger than 1. So this is going to be a negative number. Exactly what it is, I don't know. I don't care. I just know it's a negative number. So it did fit the pattern, but it won't always. So just be sure you always check. Okay. Last step, just summarize what you see. Where is it increasing? Where is it decreasing? Okay. So it's decreasing from negative infinity to pi over 3 and, or I should say, or 5 pi over 3 to positive infinity. And it, oops, wait, I keep doing that wrong. Why do I do that wrong? That's decreasing. It's negative, so it's decreasing. Increasing is in between. Pi over 3 to 5 pi over 3. I think I'm looking at the colors instead, because usually red is negative and blue is positive, but I changed it, so I don't know. I don't know what I'm doing. Negatives. And then relative maximum, relative minimum. Decreasing, increasing, decreasing. Relative minimum at x equals pi over 3 because f prime of x switches from negative to positive. Relative maximum at x equals 5 pi over 3 because f prime of x switches from positive to negative. Done.
Like, just a tiny bit.
Up?
Where I could see what you wrote for the answer.
Yeah, my answer's right here.
Yeah, because I couldn't see what you put
Yeah,
for
you don't need that. You just need this guy for the answer. Where is it decreasing? Where is it increasing? Where is it decreasing? Decreasing. That's all I'm doing here is just wrapping up what I did. So this part is not like anything new. It's just you're explaining to someone who might not know what you're doing, exactly what you were doing and why you were doing it. Okay. All right. Okay, so I'm not going to do the last one because we won't have time to answer questions on the practice. Because this week is the 12-week grading report. So anything that's been due or will be due, I'm going to grade. Okay? This week. So Friday, I have to do those things. So this assignment is due today. I'm probably not going to grade it today, but I definitely will grade it Thursday or Friday. So I want to answer questions on that as well. Okay, so go to your, let's see, here we go, questions on practice. A lot of these are the same. Like the first 4 are exactly the same. And then put the point in. tangent lines, all that good stuff. Okay, so questions, any questions? Yeah.
Number 6.
6, sure.
It's just about the answer key though. Like, so I got the equation y is 2 equals negative 1/3 times x minus 2. But I got that when x equals 2, but on the answer key it says when x equals 4.
Yeah, I don't know. Let me see. Let's check it out. So they want the equation of the tangent line when y equals 2. Well, first thing you got to do is find what x is. So you got to figure out what x is going to be. Let me find these notes. No, not that one. This one. Okay. No. All right. Let's take a look at this one. Okay. So they want me to find the equation of the tangent line when y equals negative 2. First thing I got to do is figure out what is x going to be. What is x going to be when y equals negative 2?